So, Introduction to Oceanography Final. So, for History of Science, I decided that Marie Curie was my favorite part of all of it. I loved learning about her. Um, she discovered radium and polonium, and this was like a huge thing for science. She was a woman, and a lot of women weren't as heavily involved as she was. She was also the first woman to get a Nobel Peace Prize, actually, two of them. Um, so that was really cool, and she had a huge contribution in finding cures for cancer. I just think that this was very interesting because, as I said, it wasn't super common for women to be as involved with science as she was, and in the whole unit, she was one of the only women talked about. So I definitely thought that she was the most interesting to learn about. So minerals, mineral identification is identifying minerals. So traditional, that's kind of what it looks like, what it feels like. And then there's optical mineralogy, so that's more what it looks like the different things you can tell from it. And X-ray diffraction is looking into it from X-rays to find out a little bit more about it. So rocks, magma versus lava, what is the difference? So magma is under the surface and lava has reached Earth's surface through volcanic vents, but also lava can be found on the ocean floor, which I thought was really interesting. I chose this, like, was the most interesting for me to learn about because my science classes were never extremely in depth with all of this, so it was really cool, like, figuring out the key differences between them, and that even though lava has reached Earth's surface through volcanic vents, it can still be found on the ocean floor. So, for the unit continental drift and plate tectonics, basaltic magma, this was really interesting to me because I haven't really learned about it. So, it does have the viscosity of olive oil, so very so it did surface first, and it forms igneous rock basalt. And I thought this was really cool, like comparing it and contrasting it to the other ones. But this one surfaced first. So, earthquakes, volcanoes, and hazards. I chose the seismograph to talk about. So, it records data of earthquakes, volcanic events, any seismic activity. It's installed in the ground and it records data of whatever's going on. So, like force, the distance it's affecting. It's really cool. It was discovered in AD 132 by a Chinese philosopher named Chang Hang. So it's been around for a really long time, and to this day, it is still used all around the world. The water cycle. So for this unit, we watched the Bill Nye video. I love Bill Nye. So liquid is looking for surfaces to cling to in order for the water cycle to happen. So one of the examples in the video was condensation and evaporation, where he put a little bit of water in a big glass jar and wanted to form a cloud. So he pressurized it, took it off, and nothing happened. And then he added some dust, did the same thing, and a cloud formed. And that is because the water, the liquid, is looking for surfaces to cling to in order for those things to happen. So, ocean and sediments, biogenous sediments. So they come from space, organisms like plankton, and they come from chemical reactions in the water. I chose to talk about biogenous sediments because I haven't really learned about that a lot. So that was really interesting to kind of learn about. So they're derived from skeletal remains of once living organisms. So this can be not just plankton, but a wide variety of particles like shells, microscopic organisms, coral fragments, sea urchin spines, and pieces of mollusca shells. So that was kind of cool to learn about. So air-ocean interactions. So the Coriolis effect. It makes storms swirl clockwise in the southern hemisphere and counterclockwise in the northern hemisphere. So it's a little bit opposite, which I thought was kind of cool. I've never heard of this before until this class. So inertial force that acts as objects in motion within a frame of reference that rotates with respect to an inertial frame. Because Earth rotates on its axis, circulating air is deflected toward the right in the northern hemisphere and toward the left in the southern hemisphere. and that is where the Coriolis effect comes from. So ocean circulation, upswelling and downswelling. This is also something that I haven't learned about. So it occurs when wind surfaces cause water to build up along a coastline. The surface water eventually sinks down toward the bottom, and then surface water moving away from land leads to upwelling, while downwelling occurs when surface water moves toward the land. So it's opposite again. And ocean pollution. So what we can do about ocean pollution is minimize trash, minimize plastic, support solutions. There's a lot of different fundraisers you can donate to for people working toward a bigger solution to ocean pollution, and educate other people about the effects of it, and obviously advocate for the ending of ocean pollution.